This video is on basic shifts of a quadratic. In a previous video, I explained what the a value does to a graph when we change the a from 1 to a half and 1 to a 2. This video is going to explain what happens when our a value goes from positive to negative using a 1, a negative half, and a negative 2. So the same graphs of a previous video, but we are going to be dealing with the negative value. So a negative x squared, this is not a parent function because it does have a multiplication of a negative 1. So we want to know what really happens when we have a negative in front. So if we were to plug numbers in to figure out what the graph looks like, we have 0, we're going to plug 0 in here. 0 squared is 0, times negative 1 is still 0. If we plug in 1, 1 squared is 1, times negative is a negative 1. So we have the coordinate 1, negative 1. If we plug in the negative 1 instead, so negative 1 squared is still positive 1, and then we multiply it by negative, which gives us a negative 1. Because remember, negative 1 squared, anything negative squared, turns into a positive. So it looks to be that 0, 0 is our vertex, so we should have symmetry. We'll plug in the 2. Positive 2 squared is positive 4. Then multiply by negative, we get negative 4. So 2, negative 4. Let's check to see symmetry. Negative 2. Negative 2 squared is a positive 4. Then we multiply to a negative, we get a negative 4. So we do have symmetry. If we plug in the 3, 3 squared is 9, times the negative is negative 9. So it would be 3, negative 9. That means that at negative 3, we'll also have it at negative 9 because of the symmetry behind it. We can't do any more because we would go off the graph, which is fine, but we want to do as many as we can on the graph. So let's connect our dots, our coordinates, into a parabola. So this graph right here, the parent function looked like this. So instead of it pointing up, the negative looks like it's making it point down instead. The same coordinates, but the y values have turned into a negative instead of a positive. Because we had 0, 0, 1, 1, 2, 4, and 3, 9 on the parent function. But now we have the same x values, but negative y values. So it seems to be that the graph is making it point down. So if our a value is still a half, we know that that graph will make it be wider, or the y values will go slower as it's growing. So the negative will most likely make the y values change signs to become negatives. So let's look at that. So we know that 0 squared is 0, times anything is still 0. We know that 1 squared is 1, but we have to multiply by a negative half. So that would become negative half. At negative 1 squared is still a positive 1, times a negative half would be a negative half as well. So we do have symmetry again, so we can focus on our positive values and multiply. So 2 squared is 4, times a negative half is negative 2. Using symmetry, we have negative 2 also at negative 2. So let's go to 3. 3 squared is 9, times a negative half is negative 4.5. So using the axis of symmetry, we have the same at the negative 3 coordinate. And we'll do 4. 4 squared is 16, times a negative half is negative 8. And then we'll use symmetry. So it looks to here that the graph is also pointing down again. And if we had just multiplied it by a half, all of our y values would have been the positive of it. So the y values are changing from positive to negative when we multiply it by this front number. It is still getting wider because it's a half, but now it's pointing down because it's that negative. And we want to make this as parabolic shape as possible. All right, so the negative 2x squared. We know that a 2x squared will make it wider, or sorry, more narrow, so it goes faster, that vertical stretch. So if it's negative, let's see if it makes it face down. So 0 will give us 0, 0. So 1. 1 squared is 1 times negative 2 is negative 2. So 1, negative 2. Let's try the negative 1 to see if there's symmetry. Negative 1 squared is positive 1 times negative 2 is negative 2. So we do have symmetry. We'll do our 2. 2 squared is 4 times negative 2 is negative 8. So it's at 2, negative 8. And using symmetry, we can say negative 2, negative 8 as well. We can't go any further because 3 would give us 9, and then we'd have negative 18, which is too far off the graph. So we would have our parabola facing down again, and when it was 2x squared, all of the y values were the positive of it. But now that we have a negative, all of our y values turn to negatives. So if there is a negative in front of the x squared, so if your leading coefficient is negative on the x squared, it flips the parabola. What this does, this is actually called a reflection over the x-axis. Because instead of it pointing up, it's pointing down, and it flipped over the x-axis. This was our x-axis. It was going up. Now it's pointing down, which is across the x-axis. So we have an axis of symmetry with regards to the x-axis because of the negative value here. So a negative will reflect or flip the parabola. The a value itself, just the value, will either make the parabola be wider or more narrow. So a vertical compress if it's smaller than 1, a vertical stretch if it's bigger than 1. If your value is negative, it will then also flip the parabola over the x-axis.